Hi and welcome to my channel. Today I'll be teaching you how to understand funky trees in Simpleplanes. What does it mean and how does it work? First of all, this isn't a guide about what each function does, nor it's an XML guide. Today I'll teach you the fundamentals. No programming skills are needed to understand what I'm going to tell you today, but if you have some, you'll have an easier time. Funky trees is basically math with extra steps. You should know what math is and its basics from your math lessons in school. Math operators can be used to do some simple operations on your variables. You also have comparative and boolean operators to compare values between each other. There are a bunch of inputs which are all things a player can directly interact with, for example increasing throttle or activating an activation group. You can see some of them as default options for control surfaces, rotators, pistons, and some other parts. Some of them have different ways to represent their values. Some have a range
from -1 to 1,
or they can only have two states. That's called variable type, and it's really important to know which input has which type. You can use the debug expression console command to see how they behave. These values are something that you can't directly control, such as your altitude or speed. They're read-only, so to speak. But apart from that, they're perfectly usable for funky tree math. Don't be afraid of how they're called. On practice, they're just fancy math operations. In my opinion, the simplest functions to understand are the max and min functions. Function max outputs the highest value between the two, so if x is bigger than y, it will return x. Same for the min function, but it returns the lowest value instead. Let's take a max function as an example. X will be VTOL and Y will be trim. Both VTOL and trim have a range of -1 to 1. Now let's just write that function as an input for the piston. When we load in, we'll have two of these sliders available for us, and the piston will move accordingly to the slider with the highest value. If the VTOL is at 50% and trim is at 25%, the piston will extend halfway. If the VTOL is -100% and trim is at 10%, the piston will be extended by 1/10 of its maximum reach, since 10% is 0.1 code-wise. We want for our plane to smoothly pitch and have a larger turn radius. For that we'll use the following code. So what does it do? Pitch as our own input. Pitch rate is flight data about the rate of change of our craft pitch, and 100 is the damper value. Let's look at the plane. As soon as we pitch up, our pitch value changes to -1, and our pitch rate begins to increase. Since we subtract the rate from the main input, the faster we'll pitch, the harder it will react. Matter of fact, if we won't have our damper number, we won't be able to pitch much, since pitch rate tends to be more than 1 when we pitch the plane. That's why we need the damper number. When we command our pitch to -1 and our pitch rate becomes -10 thanks to the damper number, pitch rate output becomes -0.1 and our expression output becomes -0.9, which will make us have less elevator authority. The faster we'll pull like that, the greater the effect will be, which means slower pull and smoothened pitching. Here we'll use some clamp functions. We want our aileron to combine both roll and VTOL inputs, but the output angle can't be more than what we've set it to over here in the rotator. For that we'll use the following code. Clamp function will limit its output to the YZ range. That means even if we feed it a value outside our limits, it will return the closest value that's in its limits. It's important to set the lowest value first, Y in this case. Roll is our roll input and VTOL is our input for flaps. We clamp our VTOL to -1 and 0 to prevent it from going positive, which will make the aileron go up instead of down, and we'll clamp our final output to -1 and 1, because if our roll and VTOL inputs will both be equal to -1, the addition result will be -2, which will make the rotator turn twice as much as it should. Since there's a clamp01 function which already sets the limits to 0 and 1, we can use it cleverly to simplify our code. We're inverting our vital here to make it work with the clamp01 function. Since said function outputs values between 0 and 1, and our vital input should always stay negative for our use case. It's always better to clamp your outputs to prevent them from potentially going crazy. It's good practice even though it makes the code less readable. Funky trees is really useful for making things work in a way that you want. With some curiosity and free time, you can experiment with it and apply your gained knowledge to your own creations. It's best to actually understand how it works, since copying code from someone else's craft won't teach you anything. I'll include some useful funky tree guides in the description. Thank you for your time.